Okay, let's unpack this. Have you ever watched an athlete on the field, like a basketball player juking someone, or maybe a soccer player cutting past a defender? You see those split-second changes in direction, and it just looks so smooth, right? But underneath, there's some, well, incredible science happening. Today we're taking a deep dive into exactly that, the hidden world of athletic movement. Our mission, basically, is to dig into some really cutting-edge research. It's from the Journal of Sports Science and Medicine. The paper's called Biomechanical Differences between Ipsilateral and Contralateral change of direction movements using the same planting foot in recreational team sport players. Quite a mouthful. It was published in 2025, volume 24, pages 721 to 728. And the authors are Chi-Hsien Chen, Mingchia, Chiang, Yan-Jer, Tseng, and Sung-Ting. They're from different universities in the USA and Taiwan. And this isn't just, for sports nerds. It's really about understanding how our bodies move under pressure, how tiny little adjustments can make a huge difference in performance and, importantly, injury risk. Get ready for some genuinely surprising facts, I think. Stuff that might just reshape how you think about movement.
Yeah, and the really interesting thing here is that these change of direction movements, they're absolutely critical, like fundamental actions in almost all team sports. That ability to just quickly, efficiently change your path when things get intense, that's often the decider, making the play versus missing it, staying healthy versus, well, getting injured. So understanding these subtle biomechanical differences, which this study does really well, helps us grasp not just what's happening, but why certain movements happen the way they do. It brings a certain scientific clarity, but in a way that's, still pretty accessible. That's what makes this paper so valuable.
Okay, let's start with the basics then for this deep dive. We're talking about change of direction ability, or CIADAT. This is just a crucial skill, right? Basketball, soccer, rugby, grass hockey, you name it. It's how quick and efficient an athlete is at switching course. They have to slow down, plant, and then boom, accelerate somewhere else. Think about like a point guard driving, planting hard, and cutting left. Or a winger in soccer, dribbling, planting, veering inside for a shot. That's COD. And it's not just speed. It takes technique, body control, serious lower body power.
Exactly. And without good caught-ability, you're less effective, definitely. But also the injury risk goes up. That's a big one. Now, historically, sports science has looked a lot at one type of COD. It's called contralateral COD, or just contra-COD. That's when you plant your foot, say your left foot, and then you change direction opposite to that foot. So you cut right. Researchers have studied this one inside out. Muscle activation, forces, limb differences, its role in performance and injury is kind of the classic cut we picture.
Right, the standard sharp cut. Plant left, go right.
Makes sense. But, and this is where the study really shines, filling a big gap, there's another key type. Ipsilateral COD, or Ipsi-COD. This is where you plant your foot and cut to the same side. Plant left, cut left.
Ah, okay. Like shuffling sideways, then pushing off that lead foot to move forward and left?
Precisely. Or maybe turning a corner quickly. And until now, this Ipsi-COD thing, it's been pretty unexplored. Especially the nitty-gritty details like ground reaction forces and exactly what the ankle joint is doing. Things like pronation, supination, the rolling motion or inversion, eversion, the tilting, and plantar flexion, dorsiflexion, pointing and flexing the foot. This lack of data has been a real blind spot, and this research team wanted to shed some light on it.
So seeing that gap, they decided to compare these two movements, Ipsi and Contra, directly. And crucially, they had the athletes use the same planting foot for both types of cuts. That way, any differences they saw would really be down to the direction of the cut relative to the foot, not just using a different leg or something.
Smart design.
Yeah. They wanted to know, are these biomechanically distinct or just variations on a theme? So they got 29 recreational team sport players, not pros, but people who are pretty serious, playing basketball, hockey, rugby, soccer, like 3 times a week for at least 3 years. Really relevant group.
Right. And the way they measured it was, well, pretty advanced. They had these players do 60-degree cuts, both Ipsi and Contra, a nice consistent angle. To capture the data, they used some serious kit, a 3D force plate in the floor that measures exactly how hard and which way the athlete pushes off the ground. And alongside that, a motion capture system. Think, movie special effects with the little marker.
Oh, yeah, the little dots all over them.
Exactly, but for science. Placed on specific spots on their legs to track joint angles and movements down to the finest detail. And really critically, they checked the athlete's approach speed, made sure they were running into the cut at similar speeds using their 5-meter sprint times.
Why was that so important?
Because you want to make sure any differences you see in the cut itself are actually because of the cut mechanics, not just because one person ran into it faster than another. It isolates the variable you care about, the taut technique.
Got it. So controlling for that approach speed was key.
Yeah.
Okay, so what did they find? This is where it gets interesting, right?
Definitely. And the first finding is maybe not what you'd guess.
Lay it on me. I'm thinking sharper cut, maybe more challenging. Probably means more time digging in, right? More time on the ground.
You'd think so, but nope. The study found that Ipsicod head cutting to the same side as the plant foot actually had a 6% shorter contact time than Contracod.
6% shorter. Wow, so they're getting off the ground faster when cutting in the same direction.
Exactly. Faster off the ground, which is, yeah, pretty surprising. Goes against that intuition that more effort equals more ground time.
Okay, so shorter contact time. How does the body manage that? What's happening at the ankle, for instance?
Great question. And yeah, the ankle story is fascinating too. They found significant differences in the range of motion, the ROM. For Ipsicod, they saw a 27% greater ankle pronation supination range. Remember, that's the side-to-side rolling motion.
Right, the foot rolling inwards and outwards.
Yeah. So much more of that dynamic rolling Ipsicod, like the foot's acting more like a flexible spring or rocker. But conversely, they saw a 19% smaller version range. That's the tilting of the sole inwards or outwards. And a really big drop, 37% decreased plantar flexion dorsiflexion range. That's the pointing and flexing, the up and down movement of the foot.
Whoa, okay, so let me get this straight. For Ipsicod, more rolling side to side, but less tilting and less up and down flexing.
You got it. It points to fundamentally different ankle strategies. Ipsicod seems to rely more on that rolling mechanism, whereas Contracod might involve more of that rigid up-down push and side tilt control. It's not just a small difference, it suggests entirely different ways of managing the forces.
Okay, this is building up to something really interesting. Now, the forces themselves, the ground reaction forces, this is where my intuition got flipped earlier.
Yeah.
Usually, shorter contact time, you'd think higher forces, right? Pushing harder to get off the ground quicker.
That's the common assumption, yes. Push harder, get off faster.
But this study
found the opposite for Ipsicod.
Yeah.
Significantly lower ground reaction forces, like across the board.
Lower. How much lower?
Get this. 14% lower horizontal force, so less push sideways in the direction of the cut. 32% lower vertical force, less downward push. And the resultant force, like the overall combined force, that was anywhere from 14% to a massive 279% lower compared to Contracod, depending on the specific component.
279%, that's huge.
It is. And the impulses, the total effect of the force over that contact time were also lower, around 23-24%.
So let me just process this. Shorter time on the ground and lower forces pushing off the ground. That's a real aha moment for me. It feels like they're achieving the cut more efficiently or using a different mechanism entirely, not just brute force.
Precisely. It suggests they aren't just doing the same thing faster or slower. If you tie these pieces together, the contact time, the specific ankle movements, the lower forces, it paints a clear picture.
Yeah.
Ipsicod and Contracod are not just, minor variations. They seem to involve fundamentally different biomechanical strategies, even when it's the same foot planting, same angle turn.
Right. It really challenges that idea that a cut is just a cut.
Exactly. It opens up this whole area of how we should think about, analyze, and maybe even train these different types of direction changes.
Okay, so drilling down into the why. What does this actually mean for athletes, coaches, or even just us folks curious about how bodies work? Why these big differences?
Well, the researchers suggest it boils down to a few connected things. Joint alignment during the cut, the way force is actually applied to the ground, and just the overall strategy the body uses for that specific movement. It's interconnected.
And they mentioned something about a rounded movement path.
Yes, that's a key insight. During Ipsicod, players seem to show a more rounded movement path. Think less sharp zigzag, more smooth curve.
Like carving a turn on skis versus a quick hockey stop.
That's a great analogy. That smoother carving path could naturally lead to shorter contact times and lower forces because you're not braking as hard and then reaccelerating as aggressively. It's more about redirecting existing momentum.
Okay, that makes intuitive sense. Less fighting against yourself.
Right. And there might be an anatomical reason helping this along, too. The way our lower leg is built, the fibula bone on the outside goes down a bit lower than the tibia on the inside. That structure might actually make it easier or more natural to do that rolling eversion motion, which fits with the smaller aversion range they saw. It helps the foot roll through the turn.
So anatomy might actually predispose us to that smoother rolling motion in Ipsicod? Interesting.
Potentially, yeah. It all fits together.
But wait, if it's smoother, quicker off the ground, uses less force, it sounds almost better. Why isn't it always the go-to move? Is there a catch?
That's the paradox, isn't it? Because despite seeming smoother or more efficient in some ways, the study also hinted that Ipsilateral might actually be harder to execute consistently.
Harder how?
They saw more variability in how players applied force during Ipsilateral. The coefficient of variation, basically a measure of consistency, was higher for some force metrics. This suggests it might be a more complex skill, maybe requiring finer motor control, or perhaps players just haven't trained it as much, so their technique isn't as locked in. It's not necessarily easier just because the peak forces are lower.
Okay. So maybe more technically demanding, even if physically less forceful in some respects.
Could be. And another piece of evidence supports this idea of it being fundamentally different. Unlike Contralateral, where you can usually see clear braking and propulsive phases in the force data, like hitting the brakes, then hitting the gas.
Brakes, deceleration, then acceleration.
Exactly. In Ipsilateral, they couldn't clearly distinguish those separate phases. It looked more like a continuous blended application of force. This again points to different braking strategies, maybe more integrated control, and just different technical demands overall. It really hammers home that Ipsilateral isn't just Contralateral mirrored. It operates under its own set of biomechanical rules.
Wow. Okay, this deep dive into the work by Chen and colleagues has really opened my eyes. We've learned that Ipsilateral planting and cutting the same way involves surprisingly shorter contact time.
Yep, faster off the ground.
But with significantly lower ground reaction forces.
Yeah.
Less push.
Right.
And totally distinct ankle mechanics. More rolling, less tilting and flexing.
Different strategy altogether.
It just really drives home that not all changes of direction are the same. Our intuition about these quick movements often doesn't match the science.
Absolutely. And that finding shorter contact, lower forces, specific ankle use in Ipsilateral suggests this unique balance maybe between efficiency and stability using that rounded path idea. And this knowledge, it could genuinely change how we approach sports training, maybe even injury rehab or prevention. It leaves you thinking, right, how could coaches design drills to specifically target and optimize these rounded Ipsilateral movements? Could we train that efficiency? Or, maybe more critically, how do we train to make those movements safer, knowing the specific biomechanical stresses involved, even if the peak forces are lower? It's a really provocative question for anyone working with athletes.
Definitely food for thought. If you listening are as fascinated by all this as we are, we really encourage you to check out the full article. Again, it's Biomechanical Differences Between Ipsilateral and Contralateral Change of Direction Movements Using the Same Planting Foot in Recreational Team Sport Players by Chi-Hsien Chen and the team. You can find it in the Journal of Sports Science and Medicine. It's really a foundational piece, I think, for future work in this area.
Absolutely worth the read if you're into sports science or human movement.
And hey, for more deep dives into cutting-edge research just like this one, make sure you follow our channel, turn on those notifications. That way you won't miss out on getting more essential knowledge, quickly and thoroughly. We'll be back soon with another exciting